This meeting is being recorded.
In problem 16 from chapter 20, we're asked to predict the major product for each of these following reactions. So we see here in part A that we have this acid chloride, and it is reacted with excess lithium aluminum hydride, followed by an aqueous acid workup. So we should predict that this following alcohol will be our product. So we can see where that carbonyl was. Now we have, oh, I'm sorry, we're actually one carbon shorter than that. So we'll actually have where that carbonyl was, the hydroxyl group like that. And then we can see that other methyl substituent off the side here. So again, we react this acid chloride with excess lithium aluminum hydride with the aqueous acid workup, we get this alcohol here. In part B, now we're going to react this same acid chloride with excess phenyl magnesium bromide. So if you recall that structure, the phenyl group here specifically is abbreviated pH for obvious purposes. It's a large benzene ring. So what's going to result here is that we're again going to have an alcohol with the OH group in that same position. But since we react here using this Grignard reagent, and then an acid workup, we're going to have two phenyl groups here and that original methyl substituent here on the side. In part C, now we're going to react a different acid chloride with this selective reducing agent that has this form. Instead of the lithium aluminum hydride, we have these three alkoxy groups in place of three of the hydrogens. So that's the difference. So if you see that, then we're going to produce an aldehyde after that first step. That would look something like this. And then in our next step with this ethyl magnesium bromide, Grignard reagent, we're going to produce this final alcohol product after an ethyl addition. So originally we would see this hydroxyl group here, but then we're also going to add on an ethyl from the Grignard reagent here. All right, then we have in part D, we have this dialkyl cuprate. In this case, this is a diethyl cuprate, selective carbon nucleophile. This will produce a ketone in this first step here. So we're going to get this intermediate product here. And then, that's the ethyl cuprate. So there we go. So this is our intermediate. And then we have that reducing agent, the lithium aluminum hydride with an acid workup. So we're going to, again, get an alcohol here when we reduce this secondary ketone. We're going to get this alcohol here, a secondary alcohol product. All right, now we have part E, almost there, two more to go. Now we're going to react this acid chloride, this phenyl acid chloride with our phenol here, and in the presence of pyridine. So we're going to see the replacement of the chlorine atom with the phenyl oxygen atom, and we're going to produce this ester here. So we're going to have our benzene ring, we'll have our carbonyl over here, that remains. Then we're going to have the phenyl group with the phenoxide attached here. All right, so this is going to be, again, our ester product that would result when we have an acid chloride react with this alcohol, phenol, in the presence of pyridine. Last but not least, we have now two equivalents of this amine here will result in the replacement of the chlorine atom of this acid chlorine here. And we're going to end up with this structure here. So we're going to have where the carbonyl was, we're going to insert the nitrogen from the ring, and we'll complete the rest of that. Oh, that six-membered ring like this. So this would be the product that we see when we react again two equivalents of that amine with that acid chloride.